Hey, what's going on? It's Pete, GCI Turf. And if you've been following my videos, you know that I've recently started this whole academy deal. And what it is, it's an online training course to teach folks kind of the ins and outs of growing tall fescue and how to spray some things and kill weeds and prevent weeds and fertilize and fungicides, all that kind of cool stuff. Well, I've noticed I've gotten quite a few questions on sprayers, and inside our academy we sell a couple of sprayer options, but a lot of folks already have a sprayer. Well, the questions have been sent to me in a way that they don't know how to calibrate them. They don't know what calibration is, or they may not understand calibration or anything along those lines. So I'm putting a video together right now. You're watching it, and it's going to be all about calibration and how to calibrate down to the smallest sprayer, even up to the largest sprayers that commercial lawn care companies would use, or the small sprayer that the homeowner would use. All this applies. It's one simple concept, but you can apply it to any sprayer on the face of the planet. Okay, so before we dig into this, I want you to keep in mind through this entire video this one little concept. What I have here is, what do you call this stuff? Naproxen sodium, Aleve, headache medicine, pain medicine. It says for arthritis right here. Well, there's a label on the back of this thing that recommends how much of this you take. Well, let's say I don't read the label, and that's how many of them I take. I don't take the time to read the label. I don't take the time to figure out how much of this actually goes into my body and is safe, and I just grab a handful and start chomping away. What do you think is going to happen? Well, it's not going to be good. There's a reason for this label right here. There's a reason that lawn care products have labels on them, and they tell you the amount of product per a certain area. And the base standard for the lawn care industry is per 1,000 square feet. That's how everything is dictated as far as what goes on a area, or how much of something goes on an area. It's dictated by per 1,000 square feet. You read a label of pick something, azoxystrobin fungicide. It's going to say the rate is going to be 0.2 ounces up to 0.4 ounces per 1,000 square feet. So you have a minimum amount you can put out, and you have a maximum amount you can put out at one given point in time. Okay, so why is that important? Why does that have to do with anything? Well, here's why. It's all about your equipment, and your equipment being calibrated properly to deliver that set amount of product, that 0.2 ounces or that 0.4 ounces, to that 1,000 square feet. Well, that's what's called calibration. You have to calibrate your equipment, your sprayer, your hose-in sprayer, your whatever you're using to apply that liquid to that 1,000 square foot. It has to be calibrated so that it's accurate. You can look at the back of this label and think of that as the calibration for your body. The doctors and whoever made this stuff has already done the research behind it and know how much of this goes into your body, and it's safe, and it works. It's effective on what you're using this for. So that label is somewhat of a calibration directed to your body. No different than your spray equipment. So I've got a bunch of different things sitting right here. We're gonna go over them and look at them and show you some different options of actual spray application methods, meaning the way you apply it. There's so many different ways you can put it out. There's motorized sprayers, there's backpacks, there's hose in, there's, gosh, I mean, it's just so many of them that I can't even think of all of them right now. There's just tons. I have maybe 1/10 of a 1% of example right here. And the market for this stuff is just incredibly ginormous. But the one thing that is consistent is the calibration part of it. So let's dig into that. I've got 3 examples here of a spray gun. And like I said, there's many options out there. These are 3 that we use. This is our tree and shrub. This is a JD9 Green Guard gun. This is the one we use to apply liquids to yards. It's the old Kimlon True Green style gun. Different spray tips. You can see here they make different spray tips with different size holes. See that one? These here are a little bit smaller. These are a little bit bigger. For boom type sprayers, you can see I've got a little spray boom right here. It's got 4 nozzles on them. There are all different kind of colors. These colors represent the orifice size that is down in here. You can see that 015 on there. And let's go right here and look at this one. And that's a 03 right there. That represents, the color coding represents different size orifices, which allow different amounts of product to escape. Then you have dual fan tip. See how it's got 2 fan tips right there to catch it kind of coming and going. You have single spray tip nozzles here. Just look at this, all kind of options. And like I said, I have probably 1/10 of 1% of what's out there. Here's a spray type gun that you would squeeze this nozzle and then the product would exit out the spray tip here. You've got your backpack type spray handle, spray nozzle assembly. Pressure gauges are used in calibration, and pressure relief valves are used in calibration. Now, why in the world did I go through all this trouble and show you all this junk sitting right here? Well, it's for one simple, basic reason. These are what you call a variable, all right? Calibration is simple, basic algebra, math, whatever you want to call it. So let's hop over here. I want to show you the definition of a variable and a constant. Okay, so let's talk about the variable part of this. Okay, remember the definition said variable means something that varies, something that changes. Again, what I mean by that as it relates to a sprayer is this red spray tip here is different than the orange spray tip. It varies. The red, let's see, what does this tip say? That's a 4. I think it says a 1. So the red would allow more product to escape than the orange would. And that's just so on across the board for all of this stuff. All this, like you can even look at, let's see, here's two that's the same. You can look at the hole, see the spray tip right here? You can see the hole where the product exits. The red is bigger than the yellow. That's a variable in calibration. They're different, they're not the same, it varies. Same thing over here with these spray tips that go on the end of a True Green gun. This is a variable, they're different. All right, so let's talk about constants. Okay, so now you know a little bit about variables, things that vary in a calibration or in a piece of spray equipment. Now we're going to learn about the constants. Now, this is the part you have to get right. If you don't get this right, you screw up. It's that simple. Your height, your width, your speed, and your pressure. They have to be constant. They have to be constant from the time you start spraying until the time you stop spraying. So first of all is the height. The height is, and what I mean is by height, is you take a tape measure and you measure how far this spray tip is off the ground. If you can imagine you walking with a backpack sprayer and spraying some weeds in your beds, in your mulch or whatever, you would want to hold that backpack sprayer tip, the very tip on the very end of it, down here. You would want that to be a consistent height in order for you to get a correct application. All right, the next thing is width, and back to height. When we're walking yards and spraying yards with these guns, the technicians are so well trained that they hold this gun almost within a couple of inches, the exact same height off the ground as they're spraying. Constant that has to be consistent is width. What we mean by width is how wide of a spray pattern you're making. All right, so you can look at this nozzle here, and this is what's called a fan tip nozzle. When it sits here, let me get another one and show you. Here we go. You'll better tell a lot better with this one. All right, so this is a fan. This is a little insert that would go into the end of your sprayer or in a boom sprayer, and when it sprays out, it sprays a fan tip, meaning it sprays like that, and all this is going to be your liquid inside this pattern. This is your spray pattern. It sprays in like a fan, and of course that will be turned the other way because we're not going to spray up, we're going to spray down, right? So it would be like here, and then here's your ground right here. So that's your width. Your width would be from outside edge to outside edge. Now, as you can imagine, the lower you get this spray tip to the ground, the less wide it sprays. And the higher you get it to the ground, the wider it sprays. This is why these two things combined are incredibly important. It has to be consistent, because if you're inconsistent and you go too high or too low, that makes your width different, and you just created a variable, and you have to have a constant in order for this to work. All right, so I hope you're having as much fun as I am. I absolutely eat this spray stuff alive. I thrive on it. I love it. I love putting these little fittings in the guns and putting pipe dope on them and creating things. I love it. So hopefully this is enjoyable for you as it is for me. Speed, super duper important. If you put this in 100%, these four things, you have to have, I know my math isn't right, you would think that'd be 25% each, but you have to have them 100% right on each single one of them in order for this to work. Because if one of them is off or inaccurate, that creates another variable and you get an inaccurate calibration. So speed, that means the distance it takes from you to get to point A to point B has to be the same. every single time. This one of the, for you spray guys, you'll know what I'm talking about when I say this. Some of you others may not. I'll try to explain it a little later. But that's why when you're walking the yard and your technician at the end of the day might be a little tired, and he's maybe one or two steps off his normal pace, so he just created a variable, meaning he can't keep up the same speed just because his body's unable to do it at the end of a long day. Well, that's one of the reasons that I spray at 2 gallons per 1,000 with the guns, with the spray guns, simply because it's a little more forgiving. You got a little more liquid going down on the yard, so it forgives that imperfection from the spray technician on the end of the day. So machines like the Permagreen, it runs the same speed at 8:02 in the morning as it does at 4:33 in the afternoon. The speed doesn't vary, so that makes that a far more accurate application. I want to use that example for this context. So speed is very important. You have to make, if you're walking, if you're riding, if you're on a horse spraying, if you're spraying out of the back of your truck, whatever, the speed must be consistent in order for a calibration, an accurate calibration to take place. Okay, so the last thing on the constant list, you got your height, your width, your speed, and your pressure. I'm gonna use a garden hose to illustrate what I'm talking about here. Now, my height is gonna be the same because I'm not gonna move the garden hose. I'm gonna keep it right here. My width is gonna be different depending on how far down I push this handle, but I'm going to hold it steady at the same spot. And of course, my speed is going to be constant because I'm running 0 mile an hour. I'm not moving. So to explain pressure, I've got the hose cut on. You can see it's got pressure. Now, when I just barely open this up, it's only letting a certain amount of water out. So that's one pressure. And I squeeze it a little harder, I'm getting more pressure because my orifice size just changed. My hole size just changed. When I go wide open, I'm letting the full pressure come out of the end of this hose because I've created a bigger opening in the end to allow for better flow. Okay, so I just showed you an example where I had 3 of the 4 right, okay? My height was consistent, my width was consistent, and my speed was consistent because I was going 0 mile an hour. My pressure changed 3 different times during that example. So therefore, what I'm getting at is I put out 3 different amounts of product during that time. So that's what I mean by your pressure has to be consistent. Now, most commercial type sprayers, you're gonna have something like this. It's a pressure relief valve. You can see right there, pressure relief valve. This Spraying Systems makes these. We have tons of them. They're basically used for smaller electric pump setups. Matter of fact, I got one right over here. Let's go check it out. All right, so here we go. Let's talk about this pump. And I know you're waiting on the actual calibration part. It's coming. Bear with me. I'm gonna show you. So you can see here, this is a constant. All right, this is your PSI is 100 PSI, 100 pounds per square inch. So that's a constant. This pump, it'll put out 7 gallons per minute. All right, now that's where a lot of people get confused on calibration. We're not calibrating a sprayer to the gallons per minute. We want it calibrated to gallons per 1,000 square feet, actual length times width of an area, a space in your yard. So that is a constant, but I need to change that constant because I'm not going by this gallon per minute. So how do I do that? Well, one is I add a pressure gauge. And what this pressure gauge is going to allow me to do is keep this pump running at the same PSI. Now, it says the pressure setting, that's a max PSI. It will produce 100 PSI. Now, I'm not going to run it at PSI, 100 PSI. Most of these type sprayers will run between 20 and 60, most of the time around 40 PSI. That gets you a good flow, I guess would be a good way to say it, for this type pump, for this size pump. Now, I just showed you the pressure regulator over here. This is what regulates the pressure. So you would unscrew that and you would dial this in to create more pressure, and you would unscrew it out to create less pressure. All right, so here's the basic setup. This is your suction hose coming from your tank going into the pump. The pump spins and kicks it out. This is your line that would go to your sprayer. All right, this is going to go to your sprayer, to your spray boom, your spray gun, your spray wand. In this case, we use this for our salt brine sprayer where we're putting out brine on parking lots, and this goes to the spray boom, where you can see the line continues to go, and there's a second line coming out. This line goes back up into the top of the tank. And why is that important? Okay, so let's back up. Coming suction, coming over, and I've got product coming out to my spray boom. Well, this pump will create 100 PSI and 7 gallons a minute. Well, my boom and my spray nozzles may only accept 4 gallons a minute. Okay, just for simple math. Well, that 3 gallons has to go somewhere. It can't just stay here, because if it does, something's going to explode. Something's going to blow up, or something's going to leak. It's going to leak out of your fittings or whatever. So it has to go somewhere. So your return line is basically an escape hatch, is what that is. So you would set the pressure right here, and we would set it at 40. And then that way I've got 40 PSI coming out of this going into my boom. And then the rest of my pressure is escaping and going back into the tank. So this is the way a basic sprayer setup is. So let's talk about the variable and constant one more time. This pump has a couple of variables involved with it. Well, the way I compensate for that is I add a gauge, I add a pressure relief valve, and that way I take this variable and turn it into a constant. Because see, once I get this set at 40 PSI, it's not gonna change unless I turn this handle. That's the only way that pressure is gonna change, unless this pump just gets so old and wore out that it can't produce that same 100 PSI over here. So for this reason, this reason alone, this height, width, speed, pressure, this is why, in my opinion, it's very difficult to calibrate a pump type backpack sprayer. Let me show you what I'm talking about. It's a pump type sprayer. This is one example of one where you actually have to pump this mechanism up and down that creates a pressure inside the tank, and then you squeeze this handle to relieve that pressure, and the pressure inside is what forces the liquid out. Okay, so here is another example of a backpack type pump sprayer. You would take these straps, strap this thing on your shoulder, fill it up with your liquid, and off you go. You would pump this up and down, and you see how this creates, all this is sealed. This has sealed O-rings in here that keeps the air from escaping. So as you're pumping, you're building pressure inside this tank. Well, when you squeeze the handle, it relieves that pressure and pushes the liquid out the hose. Now, if you'll notice, I keep coming back to this, and that's a reason. I'm trying to really drive these 4 points home. Why do I think, or why is it my opinion, that it's very difficult to get a pump type sprayer calibrated very accurately? Well, we can maintain a height. That wouldn't be no problem. We can maintain a width. That wouldn't be a problem, because if you keep your height right, your width is going to be the same too. These two go together, remember? If we walk at the same speed, we can keep this constant. The part we cannot keep constant, or at least for me, it's very difficult for me to keep the exact amount of pressure in that backpack sprayer by pumping it, simply because I don't have a gauge to look at. Now, before you comment and say, well, they make gauges for back, I know, I get it, I know they do. But in my situation, it just doesn't apply to what we do. So that's why we don't use we use more commercial type products, battery operated, gas powered engines, things that have pressure regulators on them. So, but for the DIY homeowner guy, this is gonna be kind of hard for you. Now, I'm not saying you can't get it pretty dang close, because you can with practice, you can get this extremely close on your calibration. But the type of calibration I'm talking about and trying to teach here is incredibly accurate. And again, why is that important? Really, it's two reasons for the lawn care company. One is so you don't over apply or under apply any product to the yard. Because in my opinion, I'm not looking at that as far as a result from an application. I mean, I am a little bit, but the more important part of that is that I'm not under providing to our clients. Meaning, if a client is paying us $100 to put this much product on the yard, then my faith and my belief system and who I am as a person, it's hard for me to sleep at night if I don't give them what they're paying me for. So to me, that's what calibration is about, is so that it upholds my integrity as far as what I tell a client, what we're gonna do. I wanna make sure what I say is what actually happens. So sorry to get off on a rant there, but that's, and of course it's a money thing. You know, we're in business to make money. So if we're over applying products, we're losing money, and that's no good. We don't want to do that. We want to be profitable in our business, and because we have bills to pay and we have employees to pay, and we want to go on vacation, and we want to buy a car from time to time, and we want to go to Chapel Hill and watch the Tar Heels play. You know, all that kind of thing costs money. So you have to be profitable in your business. Now, when you get to a larger scale, and you're spraying, now I'm not discounting a smaller operation by no means. Please do not think I'm doing that, because I'm not. But it becomes, I would say it's just as important for the small guy as the big guy, because it goes back to being profitable. If you have this much money allotted to put on this yard, and that much money allows you to buy this much product, well, you want to make sure you're doing that accurately, because if you're not, when you actually do become a larger company, that magnifies 100-fold. Meaning, if you're 50 cents off on your 1,000 square feet, well, when you get up to treating, I think last time I figured it up, I think we treat somewhere around 8.5 million square feet each application. That's a lot. That is an incredible amount. And if you're 10 cents off per 1,000 square feet, you do the math and you figure it out. That's a lot of money. So that's why calibration is so incredibly important for the lawn care guy. One, so you're not giving anybody money. Two, so you're actually giving the amount of product that you have given your word to give. And wow, this is a big deal. I want you to really get dialed in on this. This is such a big deal when we're talking about spraying, and especially when you're providing a service to a client and that client is expecting results. You have to put the right amounts of product down on the property. That can only happen with correct calibration. Okay, so I know this has been a really long, maybe boring video. I don't know, depending on what kind of stuff you like. But I'm gonna cut it off right here. I'm gonna post this one and let this sink in for a minute. Go back and watch it again. This is kind of the basic bare bones. You get the concept of the four things: the height, the width, the speed, and the pressure. They have to be consistent. They have to be constant in order to get an accurate calibration. And even though you have many variables involved in spraying, you have to factor in wind and just all kind of things that are variable. But in order to calibrate a piece of equipment correctly, those four things must be accurate: your height, your width, your speed, and your pressure. There's just no other way around it. You have to get those four things constant. So I'm going to actually need some help in the next video. It'll be a video that kind of goes along with this one. This is kind of the teaching part of it. The next part of the video will actually be hands-on, to where we're going to take a spray truck, we're going to go out here in the parking lot, and I'm going to show you how to measure your width, your height, set your pressure, set your speed, and so on. And we'll make that video probably next week, so be looking for it, and have a good one.